Hey, hello everybody. Hello, and welcome to the Arboricultural Association headquarters here in Stonehouse in the UK. My name's John Parker, and I'm the Technical Director at the Association and your chair for this event. This webinar is being brought to you by the University of Florida, and we'd like to thank the university for inviting the association to be co-host of the event and for inviting me to chair. The chat is open. I can see some of you tapping away in there already. I'd encourage all of you to say hello and tell us where you're from, but please ensure that you're typing your message to all panelists and attendees, or the audience won't be able to see your comments. And if you have any specific questions, then please ask them by using the Q&A button so that they're easier for me to keep track of. The brief disclaimer is that for some reason, we've got some high winds here in Gloucestershire, and it seems to have affected our internet. I'm not quite sure why. Hopefully it'll all hold out fine. Our speakers, which is the main draw, won't be affected, but if I disappear, hold your tears. Rob will take over and we'll find a way to sort it out afterwards. So apologies in advance for any technological problems. So any moment now, I'm going to hand over to our two presenters for this evening, both of whom will be known to many of you who've watched some of our webinar series already, because they've both already appeared in the last few months. And if you'd like to, if you like what you hear in this webinar, then you might want to check out all of the online content that's available on our website at trees.org.uk under our online learning section. And it would be remiss of me if I didn't do a little plug and just tell you all that we'll be back here on Zoom again at this time tomorrow for the third and final part of our lecture series, An Ecosystem Approach to Urban Forestry, with Rob Northrop and Michael Andrew. And you can register free for that at trees.org.uk as well. So we seem to have made it through that brief introduction without me crashing, so that's good news. That's more than enough from me. I'd now like to hand over to your presenters, Deborah Hilbert and Rob Northrop. Enjoy the event, and I will see you after the presentations for the Q&A session.
Good morning, good afternoon, or good evening, depending upon which part of the world you're from at this moment. My name is Rob Northrop, and I'm an extension forester with the University of Florida, and spend most of my time working on urban and urbanizing forests and their management. Deb?
Hey everybody, my name is Deb Hilbert. I am a PhD student at the University of Florida Urban Tree and Landscape Management Lab. I've been at the lab for about 4 years now and have had a chance to work on several projects that have direct impacts on industry practices. And this project in particular, I'm really excited about because of how far-reaching and accessible it is for different types of professionals who work in urban forestry. So yeah, I'm really looking forward to sharing it with you guys.
So I'm going to share my screen, and I'll do the first part of the program. So urban forests are valued for the aesthetic, environmental, economic benefits they provide. And even though these benefits are substantial, they do not come without costs. Damage to built infrastructure by tree roots is a major expense for practically every city in the world. 20 years ago, it was estimated in California alone that they spent $70 million annually to repair street tree damage to sidewalks, curbs, and gutters. In my home region of Tampa Bay, the city of Tampa estimates they spend about $1 million a year, and Hillsborough County spends about $900,000 a year on sidewalk and curb repair associated with tree roots. And this does not account for the backlog that exists because in Hillsborough County, they have let me know that their backlog is perhaps up to around $15 million. And this is not a problem that's isolated to here in Florida or the United States or North America. It's all over the world. In Hanover, Germany, infrastructure damage was found to be associated with about half of the 2,900 street trees that they surveyed. In Manchester, England, 30% of the street trees were causing damage to pavements, and 13% of those street trees were causing damage to curbs. These estimates do not include damage to hardscapes in parks, driveways, building foundations, parking lots, and other forms of infrastructure. For many of us, this is an idealized vision of the perfect city street. Many people think that this is what they want. They want shade, they want fairly large trees. Here in Florida in particular, we live in a semi-tropical area. We desire to have the shade, perhaps even need the shade for our own health and ability to get outside more during the warmer tropical parts of the year. This is a colorized photograph from Tampa. One of the things I believe we need to keep in mind as we go through talking about getting trees into our urban cores and planning for the new urban areas that are emerging is the idea of incorporating vegetation and in particular trees. Well, we need to realize that the history of trees in urban areas is really not that long. Yes, we can look back to even the Renaissance times when there were trees in cities, but they were not the cities that we think of today. Here is one of the oldest photographs that I've come across that depicts a deliberate use of trees to completely line a city street back in 1896. I find this particularly interesting because it looks very similar to what we do today, right? We have these narrow little grass strips between the curbs and the sidewalks, and we're planting trees in them. What's interesting about and instructive about this particular photograph is that it comes about the same time that we find we are having epidemics in cities, and the engineering profession step up and do an absolutely masterful job of dealing with sanitation problems, with water treatment problems, with the availability of fresh water, and in essence begin to create what we now today consider to be the sanitary city, or the very heavily built and engineered city of our present time. We need today, as we begin to talk about and investigate and even attempt to implement measures that lead to urban sustainability, consider the ecological context of our cities and to consider the value of these trees, not only as amenities and shade, but also the fact that we now recognize through science that the larger trees are providing the greatest benefits to our society, to our urban society. Many cities, in an attempt to keep trees along thoroughfares, which is primarily what we're talking about, rights of way, have decided to begin to use small snatcher trees, such as crepe myrtles. They're being planted in great numbers. As a matter of fact, I met a gentleman just a couple of years ago who had done a study of urban areas in the world and found out that crepe myrtles were the most common tree to be found in all the urban areas of the world. But crepe myrtles are a very small stature tree, and they do not compete at all with the larger trees that provide us with the greatest amount of benefits, the greatest value. And one of the things we need to think is that there is value to having these trees in the city. It's not, again, just not simply an amenity or an aesthetic, and that's not to suggest that those aren't important, but recent studies in Tampa have demonstrated that these trees that they have are producing benefits that support human health to the tune of about $23 million a year, and that they're actually reducing health costs to the population of Tampa by about $5.2 million a year. Recent studies that we did in Gainesville suggest the same types of outcomes. They're receiving about $24 to $25 million a year in benefits. But again, they don't come without costs. How we begin to accept and use the benefits and allow them to be available to society while reducing the costs, while doing things efficiently and economically, that's our responsibility to figure that out, not only as managers of arboriculture and forestry and engineering, but also with the help of scientists. big trees, small places, bigger curbs, right? As we continue to densify the urban core of our metropolitan regions and urbanize our regional landscapes, we're having trouble with these big trees and the damage that they're doing. The blue arrow points to the break in the curb. The break in the curb is not only an expense because it has to be repaired, but at that time when the curb is broken or is cracking, it's interfering with the conveyance system that stormwater engineers have put together to move heavy rains off the streets and off the sidewalks and to keep our neighborhoods from flooding. You can also see with the red arrows pointing that this sidewalk has been repaired many times. In this case, it was with tar, hoping that the tar would actually be more elastic and would be able to deal with the roots coming from these trees. These trees, by the way, were not blown over by a hurricane, but by a thunderstorm. One of the short-term reactionary interventions that we often see in cities is the pruning, the extreme pruning of large roots around the trees so that they can then put in new sidewalk. Sidewalk can be flattened out, can be reduce the risk, can make them more accessible to everyone, no matter what their physical capabilities are. And of course, that's very important in terms of the health of the people of our urban regions, as we've seen dramatically through this COVID epidemic, that being able to get out and walk around is important from a health and from a mental health standpoint. But when we take these short-term reactionary interventions such as this, we may in fact be leading to higher risks for infrastructure and property and personal safety damage. This is a good example, another example of a thunderstorm coming through. This is in southern Florida. You can see that these roots have been cut over time, where you can see where the red arrow is pointing to a nice flat sidewalk, all right? And this is the unintended consequence of that short-term interaction. Other things that we need to consider is the fact that our urban areas are growing. As the population of our world in all the countries, all the different parts of the world grow, our urban areas are expanding at the same time. We now talk about metropolitan regions and their dense urban cores. Those metropolitan regions are often being developed in an urbanizing fashion following public land development policies. Unfortunately, it would appear, if we look at this progression of what a typical street might look at in Florida from 1964 until the present, that these land development practices have not necessarily followed the best available scientific evidence in design elements. So we find in the bottom picture, 1990 to the present, that we have, that's a live oak that you're looking at. Live oaks can live to be 200-300 years old if placed in the proper spot, and they are enormous trees. As far as efficiency goes, as far as economic goes, they are a solid investment if they're placed in the proper place within the city, because the costs of buying the tree, putting them in the ground, and carrying them for the first 2 or 3 years until they become established is overwhelmed by the fact that they get to be very, very large, produce benefits for 200 to 300 years. But what we have here is the misunderstanding that the size of that tree is actually going to tolerate being in that space, and that it will cause damage to infrastructure, probably to the road itself, the curb and the sidewalk, and it will shorten the life of the tree tremendously. And so we change the whole dynamic of the efficiency of putting trees in the city and make them into a burden and make them into a cost in which we can never recoup. This is the insanity solution that we see today in much of Florida, as these new subdivisions, which have rapidly sprung up in the last 20 to 30 years, the trees that were put in these narrow strips of grass have now outgrown their place. They're pushing up the sidewalk, they're pushing up the driveways, they're pushing out the curbs, and they are often, the costs for these damages have been transferred to the neighborhoods themselves that have their own type of internal functioning of management of trees and sidewalks, and they incur the costs. And so these neighborhoods, these new developments, are deciding that they can't maintain those costs. It's just too high for them to handle. And so their solution is just to completely remove the streets of all trees. What's happening is often that the people that are designing the trees, the street trees, no matter whether that's the builder, the developer, the corporation that's doing it, or the plans that are being drawn up for it, are not considering the full size of the tree that will be in that site over time. And it is that full size of that tree, that mature size, that gives us the benefits back, that helps us with the new emphasis on urban sustainability. And they are simply looking at a 2 to 3 inch caliber tree, and can it fit and survive in that narrow grass space? And of course, for a short period of time, it can. But how can we take our understanding of the mature size of large trees and put that into its proper perspectives so that we create the space itself that is needed to support these large trees over time, and to coop and recoup all of the benefits that will be provided to society throughout several different generations, and not just where we are today. Deb, that's it for me. I'm going to turn it over to you right now. I'm going to stop sharing.
All right, how does that look?
Good.
Good. All right, so yeah, thank you, Rob, for giving that really good background that basically shows that a lot of this comes down to design, and we can plant trees with the ultimate goal of having the canopy benefits like shade, stormwater management, and so forth. But if we are having to remove these trees prematurely 10 years down the line, then we're forfeiting all those benefits from the tree. And the research I'm going to show you builds on some work that was done in 2015 by Eric North and Gary Johnson and Thomas Burke, as well as some other research by folks like Costello and Jones. And it helps with the design phase of situating trees in the landscape, but it also helps with retroactively predicting where you might have damage with infrastructure, as well as basically supporting your argument for having more space, or for creating more elaborate design scenarios to support trees and at their mature size. So not just the tree size at planting, but that mature size. This research was very much a collaborative effort. I can't take total credit for this. It led to a publication in the spring of 2020, which I'll show you at the end of the presentation again. But I just want to acknowledge right now the whole research team that worked on this. So it included Eric North at the University of Nebraska, Richard Hauer at the University of Wisconsin, Stephen Point, Andrew Kozer, who is my advisor at the University of Florida and kind of instigated this research project and helped to oversee it. I also had help from Drew McLean, who is our lab manager, Michael Andrew, who some of you may be familiar with from the University of Florida, and then Stephanie Parbs, who is a student researcher from the University of Wisconsin, Stephen Point. So whenever I say we, like we did this is our research, these are the folks I'm talking about. Rob did a really good job outlining the type and scale of the issue. So not only is it a problem when trees damage adjacent hardscape, but it's also a problem when trees are planted so close to hardscape, because work that's done really close to the tree roots can damage and destabilize trees. And sometimes you don't see the effects of this until 5-10 years down the road, but it really can have an effect. This picture is some renovation, includes some renovations that are going on in the town where I live currently. So I actually snuck out and got this picture a couple of days ago for this presentation. And I'm really curious to go back in a few years and see how some of these trees are doing after the grading efforts that have been done so close to the root system. So one reason having trees so close to hardscape, one reason it's a problem is because of the biology of trees themselves. So right here, I'm showing you on the left side an image of root crown anatomy. And this is a figure I adapted from the book Up by Roots by James Urban. This is an awesome book. If you're looking for a resource to learn more about the topic we're talking about right now, I highly suggest checking out this book. But basically what you're seeing is trees create this flare at the base. So because they're so top heavy and they're being swayed around by the wind, they put on reaction growth at the base to help stabilize the tree. And so it actually widens out. And that area where the trunk is widening out to meet the first roots, that's called the trunk flare. So I've highlighted that in yellow, and you can see it on the right side in the image I took. And so when you're trying to think about how much space a tree really needs, you have to consider not just the size of the trunk high up where you're normally looking at the tree, but you have to think down low where it actually widens out at that trunk flare. Then in addition to the trunk flare, we have this region called the zone of rapid taper. And this is where we have the initial roots coming out of the trunk flare. And these are the buttress roots, the structural roots, and they're usually very large, and then they will quickly taper out to a smaller size. And that's why it's called the zone of rapid taper. That region is estimated to be 4 to 6 feet, so 1.5 to almost 2 meters long, extending out from the trunk flare. So there's so much research showing that damage to associated hardscapes like curbs, pavements of any kind, it's really associated with this region, the trunk flare, and then that zone of rapid taper immediately next to the trunk flare. And so if we want to understand how to better situate trees and prevent damage, we need to understand the development of this region. So how big does it get, what influences it, and how can we predict that size? And that's exactly what we did for this research. Real quick, I do want to differentiate what I'm talking about with minimum soil volume. So research does exist for minimum soil volume recommendations. And this just has to do with how much soil is needed to support the tree, to support a healthy, mature tree. The issue is, even if you have plenty of soil, so as in this picture on the right side, this is a very long planting strip. There's plenty of soil in this strip for this Quercus laurifolia or laurel oak. But here on the left, the sidewalk has had a recent replacement because it's so close to the tree. So even though it had plenty of soil volume, it's the distance or the planting width of this strip right here that really matters. And that's what our research focuses on. It's at this ground level interaction between hardscape and then that trunk flare region of the tree. And from that, I'm going to give you some planting distance and planting space recommendations. And this is just going to add another really useful piece of information to the overall puzzle of how to support trees in urban landscapes. So minimum soil volume is still really important, but you also have to consider space. So the goals of the research included looking at damage. So we actually wanted to see, as we went along and inventoried trees, how many were associated with damage and what the relationship was between tree size and damage. We also wanted to examine the relationship between diameter at breast height, which is at 4.5 feet or 1.37 meters off the ground. And we wanted to relate that to the trunk flare diameter, which is that diameter of that region I showed you a couple slides ago at the base of the tree where it widens out to touch the start of the roots. And so I have these labeled A for diameter at breast height and B for that trunk flare region at the bottom. The trunk flare region is extremely hard to measure. It's not a typical parameter that's gathered when people are inventorying urban trees, but diameter at breast height is a very common measurement. So if we could find a way to relate trunk flare diameter to diameter at breast height, then we could easily predict it and not have to go back and remeasure all of these trees. We're also interested in whether or not things like stem girdling roots or ground cover at the planting site might affect trunk flare diameter. So we collected data on other variables too, not just those two diameter measurements. In the end, we wanted to create equations to predict trunk flare. And Along with that, we wanted to simplify them and basically produce some planting space recommendations for trees. And that's really the meat of this presentation, and why I think a lot of you are here is for that last point. And so I am going to spend a lot of the presentation talking about the actual applications. So the research took place in 3 different areas. We studied trees in Tampa, Florida, which is a subtropical region. I'm the one, Rob helped me, and then some of my colleagues came out and collected the data for the Tampa trees. So I got to see each of these individually and collect the data. We looked at 205 trees total, and we studied 2 species. And they were selected randomly from an existing tree inventory that we had on hand. And I also made sure when I was selecting the trees randomly to also get a mix of tree sizes as well as distance to hardscape, so I could really get a variety of trees to study. We also had trees in Milwaukee that were looked at. So this included 790 trees and 30 different species. And these were a part of an existing street tree inventory that's actually been going on since 1979. So these trees have been looked at for all sorts of studies. And then finally, another colleague and his team looked at trees in Minneapolis and St. Paul, Minnesota. And they looked at a total of 481 trees, which included 4 different species. And these trees included street and park trees. And I think this was extremely important because we could look at whether there was a difference in the development of the trunk flare, whether it was grown in a confined street tree right-of-way scenario versus whether it was grown in a wide lawn park situation. So here are some of the species we looked at. I'm not going to go through all of them, but I do want to point out that a lot of these species are common throughout temperate areas throughout North America as well as in Europe. And we focused on medium and large stature trees because, like Rob was saying, those are the trees that a lot of municipalities are honing in on because of their ability to provide ecosystem services. They're also the ones that tend to cause the most damage to infrastructure. The trees were studied in temperate and subtropical climates, but I don't want to lose the people who are from tropical regions, because what you can do is follow the methodology that I'm outlining and repeat it in a region with trees from your community and come up with similar results, but they will be more tailored to your trees. So I'm also going to give some tips throughout the presentation if you're dealing with more tropical species that might have larger flares or buttressing. All right, so this was fun, figuring out how to measure the trunk flare. In most cases, it's as easy as just wrapping a string or a tape around the base of the tree where it touches the ground and getting the circumference, dividing by pi to get the diameter. And we were able to do that with some of our younger trees. In our northern cities, they were able to do this with all their trees. However, in Tampa, with some of our larger oak trees, there was a lot of surface roots that were being exposed and sometimes even damaged. And so they had developed calluses and bark that was really hard to distinguish from the trunk. And so this took a lot of back and forth conversation with the research team and kind of self-calibration to make sure that we were measuring the circumference of just the trunk flare, not those outside structural roots that might be exposed on the surface. This is also common in areas where you have really highly compacted soils. Those initial surface structural roots will actually be close to the surface where they're trying to get plenty of moisture and air. So Rod actually came up with this really creative method of measuring some of the challenging trees in Tampa. What we did is we dropped a flag or a little stake at the point where the trunk tissue was transitioning to root tissue. Sometimes it's easy to tell just based on the bark. Other times we had to just basically identify what was going on with the shape of the trunk, and that helped us determine whether or not we were measuring root or trunk tissue. We dropped the flags all the way around, repeated that around the base of the tree, and then wrapped the tape around the flags, which gave us an approximate circle. And then from there we could calculate trunk flare. This ended up being a really easy and reliable and replicable methodology, so I definitely would suggest people who are measuring trunk flares that have similarly buttressing roots or a lot of exposed surface roots, this would be a very good method to use. Okay, so in addition to just measuring diameter at breast height, so at that 1.37 meters or 4.5 feet, we also got trunk flare. And then again, like I said, we were interested at what site factors or tree factors might be affecting the development of the trunk flare. So we also looked at things like, was there a stem girdling root? So one of those roots that's circling around the base of the tree and starting to strangle the base of the tree. Would that affect the development of a trunk flare? Is there a relationship between the condition of the canopy and the development of the trunk flare? We also measured things like boulevard width. We noted what the ground cover type was. We even noted whether there was permanent irrigation present, among several other variables. So here are some of the first results I'm going to show you. When we looked at damage that was adjacent to the trees we inventoried, and this included cracking, lifting, displacement of curbs or sidewalks, as well as recent replacements, we found that in Tampa, 37% of our trees were associated with damage. In Milwaukee, it was a similar trend of 39%. And then in St. Paul and Minneapolis, Minnesota, they had about 21% of their trees associated with damage. And this basically backs up other research that's been done to look at trees and infrastructure conflict. It tends to be like a good portion of street or trees in the right of way are associated with damage. Here's a little more information about how tree size was related to damage. So I'm going to explain this graph to you. What you're looking at is basically the odds that a tree was going to be associated with damage based on how big the diameter at breast height is. So on the bottom axis, you have the stem diameter increasing, and then the odds of being associated with damage on the left axis. And as you can see, the bigger the tree gets, the higher the odds of being associated with damage. And that's pretty intuitive. I think most of us would think that would be the case. And so it's always nice when our research backs up what we all kind of anecdotally and intuitively see. Now, for Milwaukee and the Twin Cities in Minnesota, we had the pavement dates and records so we could age how old that infrastructure was and compare it to our estimated age of trees and basically verify that, yeah, this tree probably did cause the damage, as opposed to maybe changes in temperature or other factors that can damage infrastructure. In Tampa, we didn't have those records, so we had to just use our best judgment in determining whether or not the tree affected the adjacent hardscape. However, the trend was the same, and I'm going to throw in some numbers to give you an idea of what this graph is saying. So basically, when we had records available for that data, a tree that had a 50 centimeter diameter at breast height was 2.4 times more likely to be associated with damage than a tree that has only a 10 centimeter diameter at breast height. For the Tampa trees that we didn't have hardscape ages for, it was a similar trend, still 2.3 times more likely than a 10 centimeter diameter at breast height tree. A cool thing about having data from the northern cities that had infrastructure age records and then the Tampa data without records is we had really similar results, which showed that visual assessments of damage associated with trees for people who are trained to look at trees, like myself, that visual assessment actually is a really good methodology. Pretty reliable if you're trying to understand how your trees are affecting adjacent hardscape. There are some other results I want to show you guys. So remember how I said we also looked at other factors with the tree and also with the site to see if it affected the trunk flare? Well, it turns out things like ground cover didn't really matter. Presence of a stem girdling root didn't really matter when we looked at all the trees and ran the statistics. It just wasn't statistically significant. Community and boulevard width did have a slight effect. So in other words, trunk flare development differed a little bit between a couple of the communities and differed a little bit based on how wide of a planting strip it had. but it was a very, very minor difference, only for a few species. And when we actually plugged in numbers and estimated the trunk flare, the difference was so minute that we just ditched it. So after all that work, collecting all that data and me learning how to code the statistical analyses, it turns out it just wasn't significant. This is actually a really good result, because what it says is now we can just keep our equations simple and just relate diameter at breast height to trunk flare diameter, and we can hand it over to folks like you to use, and you don't need to worry whether your planting strip looks a little different than the ones in Tampa or different than the ones in Milwaukee. The equations still play out. And I want to show you how close the relationship was between trunk flare diameter and diameter at breast height. So these are the results from the trees that were unique to Milwaukee. And on the bottom axis is the diameter at breast height in centimeters. On the left is trunk flare diameter in centimeters. And the closer those points are to that line, the better. So the more accurate the model is. And for all of our trees, the points were very close to that line. It was a very tight relationship. So as diameter at breast height increases for a species, trunk flare diameter is going to increase at a predictable rate. So you can predict trunk flare from diameter, which is exactly what we wanted to do. The results were similar for the trees that were shared between Milwaukee, St. Paul, and Minneapolis. There's a little more flaring for the larger trees. It does get more difficult to measure trees as they get bigger. And so there's a little bit of variation, but still strong relationships. And again, for Tampa, the relationship was really strong. So from those regression graphs I just showed you, we pulled out the equations. And these are the actual predictive equations for the different species we honed in on. And what we can do is estimate trunk flare diameter. So this little hat just means estimate. So we can estimate trunk flare diameter by multiplying the diameter at breast height by a rate that came from those graphs. And so, for example, for Acer platanoides, you would just multiply by 1.3 and get an idea of how big that trunk flare diameter is for that individual tree. Now, the trees you're interested in might not be in this list. This is a very small list of trees that we were able to create equations for, but that's okay, because what we did is we took all the trees in our data sets and we lumped them together based on their native habitat group, so whether they're upland, wetland species, or more variable species. And then we created predictive equations based on those categories. And so what you can do, if your tree isn't on the list from the previous slide, you can determine whether it belongs to one of these groups. And if you're in the United States, you would look at the USDA plants website and then click on wetland, and it'll tell you its wetland status. And so you look that up, and then you can use one of these equations to estimate trunk flare diameter. They're not going to be quite as accurate as the individual species models, but they're still based on data, still extremely useful tools. Okay, so now I want to show you guys some of the applications. Like I said, the trunk flare region is where most of this hardscape conflict is happening at surface level. And so if we want to create planting space recommendations, we need to account for the mature development of the trunk flare. But then we also have to account for that zone of rapid taper, which I showed in that tree diagram at the beginning of the presentation. Most research suggests that that zone of rapid taper, where the tree roots are the largest and most likely to cause damage, happens at around 1.2 meters out from the trunk flare. So if you want to give a tree enough space to develop without causing damage to infrastructure or without it being damaged through infrastructure management activities, you need to give it not only the trunk flare, but then a buffer zone of about 4 feet or 1.2 meters. If you're dealing with tropical species, like the silk floss tree, then you're going to need an even bigger buffer, because the buttressing on the trunk and those structural roots are a lot larger and go out a lot farther. And the best research that's out there right now says that you need at least 4 meters of buffer for those trees. That's quite a lot of space for those trees. Okay, So what I'm going to do for the rest of the presentation is show you how we took the research I just explained and we created planting space recommendations for trees that are commonly used in Florida cities. And this can act like a case study where you can take what we've done and replicate it in your own community to develop planting space recommendations for your own planting list. So you can actually have it tailored to your city. You can have it built into your urban forest management plans or your planting specs for the species in your community. I'm going to start by just outlining what we did, and then I'll go through the tables that we came up with as well as some of the equations. So again, definitely pay attention to the methodology. I'm going to give you a few different ways that you can use the numbers. And then if you have any questions, you can definitely chat or throw them into the Q&A box. But I think this is a really, really great example of how you can apply all of those equations I just showed you to practical policies and management strategies in your city. Okay, so to create planting space recommendations in Florida, what we did is we got some help from extension agents and we looked at planting lists from around the state. And we combined them and we looked at the medium and large stature trees that are being recommended on planting lists through different municipalities. And then we looked up what the maximum diameter at breast height is for those species. At first, I wanted to look through urban tree records, but we don't have a lot of long-term records of urban tree growth to show how large trees get on average in cities. And we also wanted to understand, hey, if this tree is given the maximum amount of space and all the nutrients and water it needs, how big could it get? What is that kind of maximum size? And so we actually gathered the maximum diameter at breast height by looking through champion tree registers. Sometimes they're called big tree registers or big tree list. So these are the champion trees for that species. And we looked at the champions for the state of Florida. And we called this the maximum genetic potential. So how big could this tree get if it was an all-star tree that has the genes to be massive and long-lived? Then we plugged all those maximum diameter at breast heights into the equations for habitat groups, which I showed you a couple slides ago. And from there, we were able to get the maximum trunk flare diameter. So if that tree is going to grow to be this champion size, then it's going to have a base this big. Again, we added that buffer because we have to account for the zone of rapid taper and those structural roots adjacent to the trunk flare. And then we developed tables for different planting spaces. And here's what I mean when I say planting space. So if you have a tree in, say, a lawn or in a park, but it has hardscape on one side, then I'm going to call that distance, planting distance. And so you're going to take that buffer of 1.2 meters and then add it to half of the maximum trunk flare. So you expect the trunk flare to be a certain size. Well, half of that is going to need to be added onto the buffer, and then you get your overall planting distance. If you're dealing with a planting strip or a boulevard in the right-of-way, then it's just going to be double the planting distance, or you can think of it as the total trunk flare, right? That has to be accounted for, and then the buffer on each side of that. And that's your recommended planting width. And so the table on the next page is going to show you the planting distance and the planting width recommendations for the trees that we looked at in the state of Florida. So here's the first of the tables. I know there's a lot going on, so I just pulled out two species from the list, Acer rubrum and Dilonix regia, or the Royal Poinciana. And just as examples of what you might see in Florida. And then in the column right next to that is the maximum diameter at breast height of the champion tree. So remember, we looked at those big tree list and pulled out the champion tree size for that species. Then we plugged it into the trunk flare diameter equation and got the maximum trunk flare diameter that's expected. And then what you see after this are the planting distance and planting widths based on whether the tree is going to get to be that maximum size, or if it's even only going to be 75%, 50% or 25% of that size. So for example, say we expect to plant an Acer rubrum that might end up being a champion size one day in a couple hundred years. Well, you're going to need to plant it at least 2.4 meters away from the sidewalk or street. And if you're putting it in a planting strip, then you need to give it at least 16 feet or 4.9 meters of width, which is pretty substantial. For the Royal Poinciana, it's a little bit smaller, but it still needs about 1.8 or 6 meters distance, or 3.7 meters or 12 feet width. Maybe the trees in your city aren't going to grow to be that max genetic potential. Even if they only grow to be 75, 50%, or 25% of that maximum size, you still need a lot of space. You're still going to need, for example, in the 25% of max genetic potential, you're still going to need 5 feet of distance for that tree, or 10 feet of width, which I can tell you is not allotted to trees in Florida, not on a regular basis at least. I regularly see trees planted in strips that are much smaller than that. Okay, so what if you don't know the maximum size your tree can grow to, or maybe you have a maximum diameter of tree that you would like your trees to grow to just to meet ecosystem service goals, and then after that, you don't care if you have to get rid of it. You can actually look at this next table that we created. And so what we did for this one is we have set diameter at breast height at the top. So we just picked increments of 10, 20, 30, or 40-inch tree. You're saying, okay, I expect my tree to be 10 inches diameter at breast height. Well, then we use those habitat predictor equations from the research and added the buffer. You have to include that buffer. And what you see is if you have a tree that you expect to be 10 inches, you're going to need to give it about 1.5 feet of planting distance from the curb or sidewalk, or about 5 feet. And then if you're putting it in a planting strip between two types of hardscape, then you need to give it about 2.7 meters width, or about 9 feet, and so forth. So a lot of our medium to large urban trees in Florida usually max out around 40 inches before they kind of go downhill. Even then, they need to have about 1.8 meters distance from hardscape if you want them to grow to maturity and not cause damage to surface level hardscape, or you don't want them to be damaged through trenching and redevelopment activity. With wetland species, the numbers go up a little bit because they typically have a wider flare at the base, but the trend is pretty similar for all the measurements. Okay, so we've looked at how to use the equations if you have champion tree records. We've looked at how to use the equations if you just have set diameters. I went ahead and developed another example for you, and this is if you have good records of tree sizes for your community. So in the city of Tampa, our lab has a lot of data sets because we get to collaborate with them a lot, and so we have the privilege and the luck as scientists to have a lot of tree inventory data for the city of Tampa. And I went through and I looked at how big one of our common trees, Quercus virginiana, how big that tree gets in street tree situations. And what I saw is it usually maxes out around 48 inches. We have some other ones that are bigger than that. I'm sure there's people on the call right now who are like, oh no, I know where a much larger one is. But for the most part, those are kind of the outliers. For the most part, the larger ones that you see in these right-of-way situations are 48 inches max. And so if you want to come up with a planting space recommendation using your city records like this, what you would do is you would take that maximum diameter at breast height and you would plug it into the trunk flare diameter equation, which we have for southern live oak. That was part of our research. And that'll give you the trunk flare diameter. In this case, it was 81.6 inches. Down here, I'm just converting it to feet so that I can add the buffer in feet. So sorry for everybody who's used to metric. I switched over to English units for all of the Florida folks. So you convert it and then you add that buffer on either side. And then you come up with your planting width and planting distance recommendations for that species. So for a Quercus virginiana, a southern live oak in the Tampa Bay area, based on records in the Tampa Bay area, you need a planting strip width of about 15 feet, and you need to give it at least 7.5 feet of distance from any hardscape. That's pretty significant. I live in St. Petersburg, and I've seen this species of tree recently be planted in planting strips that were only about 1 meter or 3 feet wide. And so those trees are going to grow up to cause damage. They're going to damage the infrastructure. They can also cause a threat to pedestrians who are walking. They were planted in an area that's heavily foot trafficked. And so unfortunately, 5 to 10 years from now, we're going to start seeing the root flare grow out and those supporting structural roots widen, and it's only a matter of time before that hardscape is going to have to be replaced, or the tree is going to have to be removed. Either way, it's expensive and not an ideal situation. The city of Tampa has already implemented a 10-foot distance rule for live oaks, which is good. That's a really good recommendation. And that kind of lines up with our data that we're seeing in our data sets here in Tampa. All right, so I just want to summarize the applications that I've gone over so far, as well as some additional ones. So I've talked about the 3 different ways you can use our equations to come up with minimum planting distances. So you can use your champion tree record, you can use just set diameters, or you can use records in your city if you have good records. You can also identify potential conflicts. So a lot of municipalities have existing records on sidewalk size, on planting strip size, and you can compare that against tree diameter sizes from your tree inventory data sets, and you can actually predict where conflict might be happening. So a lot of urban foresters and arborists don't have time to survey every sidewalk in their city. None of them do. But what they can do is they can actually use these equations and the data that they have on hand to highlight areas where there might be damage happening. And then they can prioritize visiting those sites and hopefully prevent, if there is damage happening, fix it, or if there isn't, they can prevent it from happening. And then finally, another application is you can use these trunk flare diameter equations to come up with stump sizes. So if you have to estimate how much of a budget to set aside for tree removals, then you can calculate stump sizes from these. Hopefully, if you are implementing better design practices using the recommendations from this research, you won't have to be taking so many trees out prematurely, and you won't have to use 0.3 as often, but it can still be used for that. So there are tons of people to thank. We had funding from several sources. We also had partners in all of our cities who helped provide data and tips on where to find trees. And then, of course, our field crew in Tampa included Brooke, Haley, Hunter, and Aaron, and they all actually helped come out and collect data with me, so I didn't have to do it alone. And so I thank everybody on this list. If you're interested in reading the research, this is the name of the publication. You can find it at Urban Forestry and Urban Greening. If you have trouble finding the publication or accessing it, you can email me, or you can find me on ResearchGate, just Deborah Hilbert, and I can maybe help you access the publication. So thank you all again for listening, and I look forward to hearing your questions.
Thank you very much, Deborah, brilliant stuff. Rob, I'm not sure if you had anything to add at the end. Did you want to bookend it with some thoughts at the end before we go into the questions?
No, that just my friend and colleague is brilliant, that's all.
Absolutely, that's fantastic. Brilliant. Thank you so much. Okay, there's loads going on in the chat. There's loads going on in the Q&A. I normally have two screens when I do this, and I've got one screen today. So I appreciate this is a first world problem I'm facing, but it is confusing me because I'm a simple man. Deborah's already covered one of the issues, which was we've had a couple of questions asking about if the article will be made available. We've already had that confirmed. The article is available, so that's nice and easy. Someone has asked if there's some CEUs or CPD over here in the UK available. Rob's got his hand raised.
Yes, there are ISA CEUs, and at 2:30, I would like to stop just for a moment and put up the code on the screen so that people can write them down.
Good stuff. Thank you very much. And for the Arb Association and for other organisations in the UK for CPD points, you can contact us and we can send you a certificate of attendance. So you're welcome to email me, john@trees.org.uk, and we can sort that out. And a few people asking if the webinar is recorded. Yes, it certainly is, and you'll be able to get it through our website at trees.org.uk, but also probably Rob and Deb will sort something out for that as well. So you'll have to forgive me as I scroll up and down all of these marvelous questions we've got. Okay, we're going to kick off with a question from Ian. And Ian says, did the data from Minneapolis give any evidence of a difference in surface route behavior in areas of hard landscape versus parkland? So do hard landscapes prompt trees to direct roots closer to the surface to offset the gas exchange shortcomings?
So I can't answer that question, unfortunately. I don't know if Eric North is one who collected that data up in Minnesota. And I don't know if he actually collected data on the appearance of surface roots, but there is evidence from other research projects that shows that when you have more compacted soil, the roots come to the surface, right? Because they need access to air and they need access to water. So typically in areas where there's less foot traffic and more organic matter in the soil, like in parks, you're not going to have those highly exposed surface roots, but I can't say for sure if we saw that in the Minnesota data.
Cool. I should say we're still getting some questions put in through the chat. If you could just put your questions through the Q&A, it'll make it a lot easier for me to manage, and it will increase your chances of having your question asked considerably. Okay, another question. Oh, I was just also going to say, sorry, I meant to say this. There was more than 520 people watching those two presentations. That's pretty cool. So thank you all for watching. That's an amazing number of people all watching together, and many hundreds are still there now. So great. Okay, next question from Andy Tipping in Barnet and the London Tree Officers Association. Hi, Andy. Andy's asking if flexible repair has been considered around trees. In Barnet and many boroughs around London and across the UK, resin-bound rubber crumb is used around street trees. And Andy's put some information in his question here that it's now policy in Barnet that material is used, and that's been signed off at a high level. So is that something you've been seeing in your studies?
I don't know if you want to take this, Rob, or me.
Sure. Well, that wasn't something we looked at, John. What we're trying to do is to get out in front of the problem. Of course, there are engineering solutions to trees in very dense hardscape areas, but they're very expensive and prohibitive in the end. And what we're suggesting is we're trying to say that we're trying to act as managers, increase efficiency, reduce costs, and get the most benefit. And so we're suggesting that needs to happen really in the beginning. The equations themselves can be used to estimate when you can expect problems from hardscape. In other words, if you've got a planting and it's getting to a certain size, and you can see that this is about the tolerable size in a planting strip for that tree, for the infrastructure, then you can say, well, maybe we should go in and this is the time to take this tree out, rather than wait until we bust up all the infrastructure and incur all that cost also. But the idea here was to be proactive, was to be part of planning, to be part of project planning, to be information to be used in terms of strategic urban forest planning.
Mm-hmm. Yeah, and you're still, no matter what pavement type you're using, based on everything I've read, you're still going to have buckling and lifting of some type if it's too close to the tree. And in the United States, that's an issue because we, have ADA rules where we have to make sure that our transportation corridors are accessible to people, whether they're in a wheelchair or have other assistance with mobility. And even if you have rubberized pavements, if they're buckling a certain height or causing any sort of conflict with people who are trying to get through the sidewalks, it's still an issue. And I do want to show you guys a couple of books real fast because they talk about some of these other design implementations, but again and again, you still have to account for trunk flare development, no matter whether you're using suspended sidewalks or a different type of pavement. So this is a good one. Up by Roots, oh, there we go. By Urban, I think probably a lot of people are familiar with this one, but it does a really good job of explaining tree biology and development, as well as some of the newer design implementations. And then there's also this one. There you go. So reducing infrastructure damage by trees. That one's by Jones and Costello. These are both really good, concise summaries of what we know so far and some actions you can take. But again, if you read the fine lines in both of those books, they say you still have to have space for the trunk flare, no matter what you're using.
Yeah, Deb, I want to say that she used an acronym right there that many people who are listening won't recognize, ADA, and that's American Disabilities Act. And that's in our country, federal monies tied to the development of transportation of any type, okay, insists that the American Disabilities Act says anybody needs to be able to access these places. And they have very strict parameters on just how much the sidewalk can buckle and how much the curb can move and access. And so it really is getting very finely granular these days within our urban areas relative to curbs and sidewalks.
As you've just mentioned some books, there's another question that I've now just lost because I have to scroll up and down and it's all terrible and I hate it and I want to cry. No, okay, let's ignore that because I managed to lose it. Okay, this is terrible, isn't it? Look at this, I fall apart when I don't have my technology. Right, question from, we'll come back to that one about books. Question from Naomi. Hi, Naomi. If a tree is staked using the traditional above ground staking procedure, how can you predict trunk flare when restricting movement usually disables the tree's ability to develop a flare? So a bit of a critique of the standard tree planting methodology there from Naomi.
Yeah, so I can't say for certain for the northern trees, but I know that many of the trees in Tampa that were planted were staked for the initial couple of years. And then the stakes are removed. And that's the ideal situation, is you're removing the stakes after a year or two so that you can get that development of trunk flare. And that's the typical practice with the trees we were looking at in Tampa. So they were still developing trunk flares. And some of the older trees that we looked at, the really large ones, probably were in growth and weren't even planted and probably weren't staked at all. And so we still had a really strong relationship between those trees and the newer trees. So it's not something we looked at specifically. That's a really great point. Good thinking. But I think we had enough variability, at least in the Tampa data sets, to show that they still were developing trunk flares. Rob and I also went out and measured trees in a park, a couple of different parks. This wasn't published because we were kind of testing out our methodology at that time, but I went ahead and ran some statistics on it. And the trunk flare development in those park trees was also similar to the trees in the streets. We just didn't have a large enough data set to publish it, but the trend was the same.
Yeah, and Deb, you know, right now we're not talking about the science, right? I mean, please understand, people are asking us questions and we're giving our opinion. So the opinion here, down here, is that when we stake a tree, we stake it for a year. And that's it. So that's not going to terribly inhibit the ability of a tree to develop the trunk flare. The trunk flare develops over many, many years. And of course, even when you properly stake a tree, you're providing room for the movement of the trunk with wind, and that's stimulating the growth, the taper of the tree, and the development of the flare at the base. And so, as long as you're not totally constraining that tree and keeping it from moving at all, I don't imagine that there would be any effect on trunk flare development.
Yeah, that's a good point.
Okay, so something that may have an impact on the root flare or trunk flare. Question from Ethan: did the research capture soil types and the potential impact of different soil types on your measurements?
We didn't look at soil types. We looked at ground cover and some other factors like that. But what we found is the relationships between the almost 800 trees in Milwaukee and the shared species between Milwaukee and the Minneapolis trees, which were in slightly different soil pit conditions. They still had very similar trunk flare development. So I don't suspect it's going to be an issue. And that's part of the reason why we also looked at differences between park and street trees too. Because soil pit, soil is a lot different than the soil you're going to find in a park setting, at least here in the United States. There's so much grading and compaction and the bringing in of urban soils into those tree pit situations that it's a lot different than what you're finding out in the park. So again, yeah, we didn't see it pan out that way. Yeah, and that's actually, oh, go ahead.
No, go ahead, finish, I'm sorry.
Yeah. I know I'm not supposed to be talking about the science too much, so I'll keep this quick. But a lot of times what we'll do as scientists is we'll collect information, especially for observational studies like this. Like there's no way we could have collected soil samples for 800 different tree pits in one city or thousands of trees. So what we'll do is we'll look at proxies. So ground cover type is a good proxy of the soil condition underneath, for example. Or if you have constant irrigation, you're probably going to have slightly different soil develop over time. And so we take these measurements that are easier but are related to act kind of as a proxy for those more difficult things to collect. And in the end, there wasn't a difference, which was good news for all of us.
And Deb, I think the large sample size, okay, was a very, very randomly picked large sample size across at least two very different climactic zones with very different geologies, very different hydrologic functions, very different climactic aspects that affect growth and shoot development and all kinds of things. And the fact that you were able to look at this greatly disparate set and it all came together was an indication that the soil was likely not playing a role in this. And by the way, for the person who asked that, I say that being somebody who studied soil, so I don't discount soils at all. But I think in this study that it became a moot point.
I can see some good conversation about soils going on in the chat. There's another couple of questions. I think they're on the same sort of theme, but maybe even not just about trunk flare. One from Jamie about structural soils and things like silver cells and that kind of underground infrastructure you can put in. And one from anonymous attendee who's watched all of our webinars so far and has submitted a question every week. So thank you, anonymous.
Cool.
What is pretty committed, huh? What do you think about alternatives to soil such as stone beds or structural soil? So it's similar to the question you just asked, but I suppose more broadly, just in general planting terms and how trees cope with that and maybe how to get them into the ground in the first place.
Right. So it's It's kind of a different topic. I mean, structural soil, like CU soil, structural soils or similar technologies, they help with the vigor of the tree. They provide a lower bulk density, so the soil isn't as compacted, and so it allows for more vigorous root growth. But it's kind of a separate story than what we're talking about, which is that surface level interaction. So even if you're planting in structural soils, which are a lot of times better than that highly compacted urban soil, you still need to give the tree space. You still have to account for trunk flare and, right? I mean, yeah, it's just another piece of the puzzle.
It's just a different kind of soil.
Right.
So a different soil, same principle. A lot of people have asked, I mean, 6 or 7 people have asked, let's pick a Laura, who I've just seen there, about root barriers. Any thoughts on root barriers? Have you done tests with root barriers? David asked if root barriers can prevent damage to hardscape. Laura specifically asked, were root barriers considered in planting width recommendations? And do you think that these recommendations would be a good justification for requiring root barriers where the required planting widths can't be met?
Okay, a lot of questions there. So we didn't look at development of trunk flare near root barriers. I suspect it wouldn't matter. I mean, again, especially with our like vigorously growing, wide flared laurel and live oaks down here, they're just gonna like grow. If you have like a vertical barrier, they're probably just going to ooze over the edge of the barrier, at least at the surface. So what they're meant to do, at least with the vertical barriers, is deflect the roots downwards and then go under the hardscape. And the research is really variable. I've read, as far as I know, all the most recent literature on the use of different barrier techniques, and the consensus seems to be that the places where these barriers work the best are where we need them the least. So they work really well in well-drained, uncompacted soils. They do a really good job of deflecting roots down and under and away if you have nice soil. But in urban areas, we don't have nice soil usually. And so the barriers aren't working as well there. And it just, yeah, I mean, it varies. All the research is very different. I think that last point that the question asker made about how maybe the trunk flare equations can be used as evidence of why you might need to implement some new technology. Absolutely. Like, I think we do need to do more research on the relationship between trunk flare size and root barriers, but what I've showed you should certainly be evidence enough that what we're using now in our planting situations is not enough. So it's certainly evidence for that. Do you have anything to add, Rob?
No, just a little hypothetical that, you know, we're talking about trunk flare and the major roots. Mm-hmm. And root barriers are not intended to deflect them. They are intended to deflect the smaller, loose, I don't want to call it loose, but the lighter roots, the finer roots that can be bent and deflected. Once a tree has formed a wood, as in the flare or in those major structural roots, they cannot be deflected. There's no turning them. And so the root barriers were never intended to turn those in any direction. They can't do it.
Okay, thank you very much. Right, we've had a question, Rob, about the CEUs and the fact you said it was going to appear at past, and I think a few people thought that this was an hour or just an hour and a half long, and there's consternation in the ranks that they're not going to see the code.
The consternation. Okay, I can appreciate that. There was a little bit of confusion initially about how long this would be. John, I'm going to grab the screen and just throw it up right now. So everybody, I'm going to put on the screen. I'm going to put it up here right now. I think he says, let's see. So here you go. What you're looking at is the course code. And that's what you need. And in order to get the CEUs, you will use these codes. And to use these codes, if you don't know how to do this on your own through ISA, contact your local ISA chapter or contact ISA's headquarters in Atlanta, Georgia, and they will tell you how to use these codes and apply to get the CEUs. For this particular program, they awarded 1.5 CEUs. And that was for a number of different categories. The ones I truly remember are certified arborists, board certified arborists, and municipal arborists. There may have been more. So, John, if you want to keep going, we can just leave this up here for a minute.
Yeah, sure. That's cool. We've got another new one on me, Rob. Anonymous attendee's been back on again. Will you be offering Florida Landscape Architects LACES credits for our RLA CEUs? I'm asking questions I don't understand now, so.
Yeah, I got that. No.
That's the shortest answer you're ever going to get from Rob Northrop. No. Cool. Okay, that's that one as well. Right. Okay. Question from Richard. Let's have a bit of an opposing perspective. Richard says planning is great. I've got a feeling Richard might mean planting is great, but correct me if I'm wrong. Planting is great, but there are millions of trees currently damaging hardscapes. Is there a solution?
There are many temporary interventions that we can take. Whether they are appropriate for a given project or whether they in fact are economically viable or efficient, that has to be determined on a site-by-site basis. I can tell you that the one book that Deb pulled up by Costello, a compendium on, I forget the name of it. Show it again, Deb.
Sure.
Because that's a good one.
Yeah, this is a really good one.
Yeah, reducing infrastructure damage by tree roots. This was a great group of people that came together, about 10 years ago, and talk about different interventions, engineering interventions, and different interventions that are tree related in terms of how to manage trees. But unfortunately, we're going to keep having these problems, and I guess what we're kind of saying also, and I hope that you tune in tomorrow for our last part of our discussion of an ecosystem approach to urban forestry, is that today in the epoch of the Anthropocene, our metropolitan regions are really growing, and they're growing rapidly. And we have an excellent opportunity not to make the same mistakes we made in the past. And everything else within the cities is a case-by-case basis. I think the big opportunity, though, is to not make these mistakes in the past. And what this research demonstrates is that we have the science to allow us not to make those mistakes in the past, and to ensure that the cities that we develop do have the opportunity to incorporate the green infrastructure to support the ecosystem services that are fundamental to our achieving some level of urban sustainability.
Okay, good stuff. So a quick question, might be a longer answer from Rahul. What is the scientific basis of the buffer distance?
Yeah, that's a great question. So it comes from a few different publications. And if you just email me, I can share those titles with you because I can't think of all of them off the top of my head. But they were looking, like one of them was looking at how far away from the trunk flare you can do trenching or construction activity without severely affecting the tree. Other ones actually exposed the root plates and looked at the zone of rapid taper at the anatomy. And they all kind of came up with similar figures of how far out that extends. But there's still some research to be done in that field for sure. So that's kind of our best guess from a few different publications in temperate North America. And there's really only one on tropical trees that I know of. at least in English. There might be some other publications in other languages talking about tropical trees, but yeah, it's a combination of looking at trees and infrastructure and also just looking at the anatomy of the root plates.
Anything to add, Rob?
No, thank you. Deb, thank you.
Okay, so a question from Andy. Hi, Andy. Hope you're doing well. Nice to see you watching. Andy says, thanks for a great presentation. Definitely agree with that. Do you think there's a risk that only small stature trees are planted in urban areas if large trees are only planted in very large verges, which often don't exist in cities? This could have a big impact on urban tree cover over time.
We're already seeing it.
Mm-hmm.
Okay, I mean, we're already seeing that happen, and of course that's occurring. The driver of that is the densification of the urban core of the metropolitan regions, and there's kind of like contrary things going on here relative to sustainability, because sustainability suggests that if we can get more people to live efficiently on smaller pieces of land, that we can keep more of the natural wild infrastructure in place. So we're going to see that. We're seeing that trend in Tampa. We're seeing it in Gainesville. These are two places where we've been working with, as Deb mentioned earlier, we've been working in Gainesville very actively for 15 years. So we're seeing that happen. And we recognize when we look at the data from the ecological analysis, and we look at this particular species of trees and the sizes of those trees that are giving us the fundamental biggest bang for the buck in terms of human health, air quality, shade, reduction of fossil fuel use, carbon sequestration. These are coming from the big trees. Okay, so we're not making an argument that we need to get rid of the big trees. What we're actually doing is making the argument is that the next time around, and that next time around is right now, as we're building our new cities, right now, that these big trees are really important, and we need to take into consideration that they need the space to exist, and they need that space to provide those services, but they also need that space to reduce the level of maintenance that they will need over their lifetime and reduce the costs of management to the cities.
Okay, good stuff. Right, we've been going for like an hour and a half now, but we still have like almost 400 people watching, so that's pretty cool. None of you've got social lives, or we should just keep going. I'm not sure which it is. We're going to link up two questions here because that's how we like to do things. First of all, this is a two-part thing. Bear with me. Isabella. Hi, Isabella.
Hi, Isabella.
Isabella says, hello, Deb. This is weird. It's like reading out someone's text message.
Hey, Isabella.
Hi, Deb. Yeah. It's Isabella from the University of Sao Paulo. We talked on Instagram.
Know Isabella.
This is a weird...
Know her?
So Isabella says hi. Now, Isabella's also researching tree roots and is saying she'd like to know how to proceed about the distances when most of the surroundings of the tree space is impervious pavement, which is the most common here in Brazil. Mm-hmm. So bear that in mind, because I'd also, just because we like showing off just how fantastic a range of audience we've got, Priyanka, who is in India working in Mumbai, Priyanka's saying that the dense grey structure is a big constraint for urban green spaces there, and how can the designing field be incorporated into their study? So again, just going to show two very similar issues, one in India, one in Brazil. We really are all facing the same problem. So what's your thoughts on that?
Yeah. Hey, Isabella. The research, again, if anything, is just showing that we need to approach development differently. We're not looking at ways of getting around hardscape with the research that we did. Instead, we were just looking solely at the biology of the tree and how it grows, and then what happens when it's too close to infrastructure. And there you go. There's the evidence to say that maybe the way we've been going about things as far as the amount of impervious surfaces that we're using in the small green spaces, it's just not going to work long term. If you have more questions, let me know. Rob, would you like to add something to that?
Yeah, I'd like to suggest something. I spent most of my life as a manager, so I know that solving problems is not always so easy. But if we think about the benefits that the trees, the ecosystem benefits that they provide to urban areas, we know that the bigger trees provide the most in any given year because they have a larger leaf area, and that leaf area is providing, at least at this point, what we can measure, a great number of the ecosystem services that they provide. But there's another element to this, is how long do the trees live? How long do they live? So if we've got small spaces where we can't have the big trees, can we identify the smaller species of trees that have long life cycles, that can exist in those spaces for very, very long times and continue to function with a reduced amounts of maintenance and reduced damage to the physical infrastructure? It's a compromise. Obviously, you'd like the big ones that live really long, like the Virginia, like the southern live oak that we have here. But if we can get medium-sized trees that can fit in those spaces and that live a long time, then the benefits to the costs are also going to be in our favor. The other thing is, of course, and we're missing this point, and tomorrow, of course, Andrew and I will bring it up and talk about it, is that in urban forestry, it is not just the space for the tree. In the long run, as we plan for the emergence of these bigger metropolitan regions and these bigger cities, it is the maintenance of the forest itself. That the tree, every time that we take it out of the forest and putting it into a situation like this, is immediately stressed, no matter what we do. So, in terms of planning, it's what Deb is talking about. If we have to have individual trees and we have the infrastructure that we're going to place around it, we need this amount of space. But ideally, what we want to do is we want to keep patches of the forest intact. That's it.
Yeah, quite right. I've just seen a comment, I think Isabella again, actually, just saying which came first, the root or the crack when it comes to damaging infrastructure. The standard tree officer line in the UK is that roots don't damage drains, they exploit existing weaknesses. So yeah, you should be maintaining your drains properly. Okay.
Well.
Come on, Rob, don't argue.
I agree, John.
That's fine. We'll take that. Okay. Frank has a question. Frank wants all the work done for him, I think. Great research for Florida. Has this been distilled into a simple guide of, for species X, provide Y planting distance, provide X planting width? And if so, where can we find this resource that tells us exactly what to plant?
Yes, so we did write up an extension article, so for the University of Florida Extension Publications, EDIS, and I don't know when it's going to be published. So if you're really eager to get a look at these tables, definitely reach out to Rob or myself and we can help you with that, because we definitely want these to be implemented as soon as possible. But hopefully in the next year it'll come out as an EDIS article.
And I'll tell you, Deb, that as soon as the university publishes it, I will take it and I will use all the mailing lists that I contacted all of you in Florida by to come to this webinar, and I will distribute that to everybody. So it'll be coming, and it'll be coming out. It'll be being sent out through ISA, through the Florida Urban Forest Council, through the Tree City network. And then also through all the different extension offices in all the different counties throughout the state.
Thank you very much. I should say, I apologise in advance to everyone whose questions I'm not going to be able to ask. We've just got vast numbers of questions. I think we've almost got like 70 or 80 questions today, so it's really provoked some debate. We'll get through as many as we can. How long we got, folks? You happy? Another 10, 15 minutes? Can you go with that? Yeah.
Oh, sure.
Everyone's having fun. We've still got more than 300 people watching. So another anonymous question, unfortunately, because it's a good question. Will you relate DBH and TFD to leaf area and or canopy area, since these are the areas often tied to tree benefits?
Yes. So whoever asked that question is good thinker. So we've actually talked about this, Rob and I have, and there are some equations that exist already that relate DBH to canopy size. That's some work that people like Dave Nowak has done with the USDA Forest Service and Greg McPherson and some others. So you can find that. A lot of times those are tailored to common temperate species. So we need to do a little bit more work on some of the subtropical and tropical species. And then, yeah, Rob and I have talked about maybe looking at some of the differences and benefits based on different sizes of trees.
Yeah, I think that's, and again, we did talk about this. We talked about it because we totally agree with you. That's a great tool. That's a nice full tool then. You know, you'll be able to recognize the space that you need, and you'll be able to recognize the benefits. And so you can begin to computate the costs, the full costs and benefits all in one table. So maybe next year.
Yeah.
Right, so I finally found, after just about an hour, the question I was looking for ages ago from Daniel in relation to the fact you've just been showing some books. Daniel says, for cities looking to improve their street tree planting guidelines, what are some of your preferred reference books or standards? Where have they gotten it right? So you've shown a couple of your favorite reference books, you might have more, but without trying to put you on the spot too much, you got any examples of where's really done well with this?
I don't know, do you want to go first, Rob?
There's not too many places.
Yeah.
Okay, I mean, and quite frankly, I've never seen it done really well, except in very isolated instances. Mostly when I've seen older, higher end neighborhoods and cities where they have true boulevards, you know, in the middle of the street, and really it's a mini park is what they turn out to be, and in those mini parks they'll have trees planted, you know, and spaced accordingly, and probably done by a knowledgeable landscape architect who was looking to create that sense of a mini park and really wanted to get the full aesthetic value of the crown of the tree, and was really doing it very consciously. About the only times I've really seen it done that way. That's why I brought in that picture from 1896. We really haven't progressed a whole lot beyond what was being done in 1896. These spaces are entirely too small. Deb?
Yeah, so I know they've done some experimental things in Southern California and like Santa Monica and Santa Barbara. A lot of times they go back 10 years later though and find that even then they didn't give the trunk flare enough space. But what I did like about those projects on there is they were getting really creative with landscape architects and engineers to test out new technologies. So a lot of like the Silvacell technology was totally just like a test run for these municipalities, and you kind of have to take a risk sometimes. A risk with an educated guess, right, where you're working with knowledgeable engineers and landscape architects and arborists, but you do have to go out on a limb and be that city that's going to try something new. And I'm really curious to see what people come up with once they start implementing the evidence that we've shown here. I have seen, I can't remember the city, but there's a movement to get rid of parking spaces. And I forget what it's called, whether it's like a push out, or I can't remember the term for it, but basically you are extending the planting pit to make it larger. you're getting rid of parking as a downside. Sometimes it can, a bump out. Someone just said a bump out. Thank you. Yes, a bump out. And that can expand the space for the tree. But again, you're going to have to work as a group at the city to decide whether that's going to work for your community or how you're going to make it work.
And we've seen that type of style of doing it coming out of Denmark, looking at re-engineering streets to slow traffic down, and doing that in a way that makes the streetscapes themselves more appropriate for pedestrians, at the expense of being less appropriate for cars, and that means creating those spaces and creating bigger areas. Again, still going to be very hard, even in those situations, to put Quercus virginiana in there. Really big trees.
Yeah.
I'm loving bump outs. I'm learning all sorts of new terms today. This is a good day. On that theme, I have to ask a question because it's going to be the most American question I've ever asked, and I love it. I want to say Dana, it's probably Dana, apologies. In Philly, a lot of our neighborhoods have row houses and only have space for 3 foot by 3 foot or 4 foot by 4 foot street tree pit opening. So are you saying that no trees should be planted in these spaces? And sort of how about the smallest of the small stature? And then following up from that question is, James has asked something similar. I think this is probably the big question. How do we get developers to give up 8 more feet for right of way so we can put sidewalks 14 to 16 feet from the edge of the pavement?
Deb, do you want to do the first one about the small pits?
Sure. Yeah, if you want to avoid damage to hardscape, then you're not going to be able to plant these large stature trees. So you're going to have to go with smaller trees. And another thing to consider in those really small spaces is soil volume. So what many cities have done when you have those really small 3x3s is they've made sure they're connected underground. So even though all you're seeing is 3x3, it's actually a long continual strip of soil volume underneath, and that allows the roots to grow out and to share space with each other, which is what they do in the wild anyways. A lot of times the roots are communicating and grafting and sharing resources. So that's a way to deal with soil volume. But again, you still need to have space for the trunk flare, in which case you're going to be limited to small trees.
And by the way, to the Dana, I spent a great deal of time in Philadelphia. I'm actually from the Chesapeake Bay region. So I know what you're talking about. And at this point, we have to make sure that we do not totally discount the aesthetic value of trees. And that's a feeling, that's an emotional input that we get from having them around. So, while it's on a citywide basis, if you're looking at sustainability and ecosystem services, putting small trees in those pits outside the row homes in Philly, which by the way are really beautiful looking lots of times, is a beautiful accent point. And if the tree only lives for 10 years, maybe that's okay. Maybe you say, hey, I want that aesthetic. That's a beautiful aesthetic. It's going to live for 10 years. That's not an unreasonable cost for me to do that. So we have to remember that. So the next question is, so how do we get developers? Well, it's not developers. Okay, it has to do with public land policy and land use policy, and it has to do with public health, and those things are decided based upon, at least in our country, are based upon the values of the public. The values of the public determine who become the politicians and who the political body gets to be. It is through consensus that laws are written, that land use ordinances are developed. So I think the answer to this really is that if this isn't happening, then we as engineers and arborists and foresters and conservationists and citizens have a great educational opportunity. We need to get the folks in our regions, in our cities, to recognize that this is the only way that you can have this urban forest and you can have all this greenery, is to give it space. And then if they accept that and they put that into their value system, then they will vote for and put in place the political body that will create those ordinances. Developers themselves, that's not their problem. Their problem is they just want to know what the playing field is. And they want to make sure that that playing field, all those regulations and ordinances apply to everybody that they have to compete with. As long as that's true, they can create a business model that works. So I think you just identified one of the major things that needs to occur very soon, and that is an effort to educate, and I don't mean to act like people are empty vessels and we want to shove information in them, but to teach them about what Deb just taught us all about a little bit about what she learned, and that's helped us better understand it. We need to share this with everyone. Whether you've got newsletters, whether you've got workshops you go to, whether you get to talk to different people, take this research and take it with you and say, look, if we want green infrastructure, if we want urban sustainability that incorporates green infrastructure into that system, then the evidence is being shown to us that we need to allow that space to exist for that infrastructure to exist and to thrive.
Well said, absolutely. Okay, what time is it? Okay, let's try and go for one more maybe. A few people have been asking for specific links or asking names of the books and various things. We'll make sure all of that is available. It can be in the information that goes with the webinar online. A couple of people have asked what my email address was. It's john@trees.org.uk. So feel free to email me and I'll pass you whatever information you like. Question from Jeremy. Maybe we'll try and make that the last one. Jeremy has recently changed the standards for his city and encouraged the use of recessed tree pits, mostly for rainwater runoff collection. Assuming roots are able to grow under the sidewalk, would recessed pits be beneficial for allowing root flare with less damage to the surface?
You'll have to explain to me what a recessed pit is.
Yeah,
I'm a biologist.
I'm not sure either, John, what a recessed pit is.
I'm assuming, and if I'm wrong, Jeremy, or someone else shout at me, I'm assuming it possibly means it's set lower level. Is that what I mean? I'm thinking for surface water, sometimes like a sort of incorporating into a sud system. So if I'm wrong, Jeremy, there we go. Jeremy, this technology is great. Jeremy says it's set lower than the sidewalk level.
Gotcha.
Rob's been asked to sign off the session with a song on the guitar. I can't believe someone's actually asked that, and he's been desperate for weeks for someone to ask that. But let's talk about recessed pits first.
Okay. Yeah, from what I've read about using, in my mind, I always call it suspended pavement. But yeah, I guess the opposite would be a recessed pit. You still need to think about the trunk flare development. So unless you're going way far down, you're still going to think about how the base is going to be wider than diameter at breast height. And then as far as the buffer zone, that's kind of the question that's still out there. As scientists, we're not sure how the buffer zone would change if you are using suspended sidewalks or recessed pits. So you still need the trunk flare. Buffer zone could go smaller, but I really don't know.
Rob, any thoughts?
No.
I know that in the UK, I've seen when there's been talk of using sort of recessed tree pits, a big fear that they could be trip hazards. Basically, we're very keen to try and keep the sidewalk on exactly the same level as the surface material around the tree. And if you start dropping down to significant differences, that's a real trip hazard problem. So, a quick plug, I think, for the London Tree Officers Association, the LTOA, who did a very good document a few years ago called Surface Materials Around Trees in Hard Landscapes. And you can get that from their website. We can put that link somewhere as well. But that looks at many of the different kinds of materials you can use around trees in urban areas and some of the pros and cons of that. So please feel free to check that out. There's loads of questions left. We're not going to be able to go through them all. What I will say is all of the questions and all of the chat we will send on to Rob and Deborah afterwards. And I know from previous webinars, you may well get a response. So careful what you wish for. You might get an email answering your question.
My emails are much more brief and concise.
If there's anything particular you'd like me to take up with them, again, john@trees.org.uk, please let us know. This will be on our website soon. Please do tune in for tomorrow's webinar, again, with Rob, with Michael Andrew. It's going to be really, really great. And now I'd like to invite Rob Northrop to play us out on his guitar by popular demand.
It's not in tune.
Oh.
Oh, I see. Neither's mine.
Okay.
Yeah.
I'm not sure you're going to be able to hear it properly because Zoom is not a guitar friendly thing.
Before he starts, Naomi's just said we need the ISA code. That was provided, Naomi, and it will be on the recording, so we'll make that available to you, I promise. Sorry.
Yeah, we'll put it out there. Okay, so we'll do Corina, Corina, where you been so long? Corina, Corina, where you been so long? I've been thinking about you, baby. Honey, please come home. I got a bell that whistles. I got a bird that sings. I got a bird that whistles. I got a bird that sings. But if I ain't got Corina, life don't mean a thing. Goodbye, folks. See you tomorrow.
You're a legend, Rob. I love you. You're a star. I wasn't expecting that. Everybody, thank you so much. Go safely. Hopefully we'll see you tomorrow, and if not, again soon. Stay safe, everyone. Thank you for joining us. Rob, Deborah, you're absolutely brilliant. Thank you so much.